Welcome back, everybody. Welcome back to Math 1314, Chapter 5, Section 3. This is more on math. This is dealing with the homework assignment. First question, Chapter 5, Section 3 homework. Graph the equation on paper and then choose the correct graph. All right, so in order to make it a graph, we have to convert that. We have to convert that into, we need to make it y equals some function of x. Remember, whenever you have a function with a variable on, we have to get rid of that. We have to somehow transform it. This is a transformation. This equation is from there. So our base is 6. So we know it's log base 6. There's the y, and there's the x. So when you convert these to that, the a goes from being with at y, now it's with the x. So it's log base 6 of x equals y. That's a linear equation? No. Exponential? No. That's a quadratic, radical. This is square root plus or minus square root of x. That's not right. So it's got to be this. It goes, remember, this function, the logarithmic function, crosses at 1, and its asymptote is the y-axis. So the first one's B. Same thing here. So we have x equals 1/6 y. That's your base. So it's log of 1/6, switch x and y. Remember, in exponentials, when x is greater than 1, it's like this. When x is between, it's like this. The same thing happens with logarithms. With logarithms, if a is greater than 1, the logarithm looks the normal one. If it's between, then it looks like this. So all that means is now, since that's a 1/6, it'll be a decreasing function. No horizontal shift, so it can't be that one. Remember, the y-axis is your asymptote. Don't know what that is. That's the wrong direction, so it has to be D, because the asymptote is the y-axis. All right. Well, there's a property. The property says this. Let's see why that is. ln is log base e of 1 equals some number. We don't know what it is yet, but it's log base e. Convert it to exponentials. E to the power x equals 1. Only way anything can equal 1 with a power is if x equals 0. So it's 0. This one, we know the answer is going to be -4. It's one of the properties. If the base and the base of the equation are the same, it's just the exponent. Log of 10, this is log base 10. If there's nothing there, it's automatically log base 10. So since these are the same, That thing comes out in front. We get negative 4 log base 10 of 10. This is equal to 1, so it's negative 4. Find the logarithm. Number 5. This one, identical to this one. Whenever you have a function of 1, it has to be 0. Log of 29, base 29 of 1 equals some number x. The 29 pushes up the x, log drops off. So it's 29 to the power x equals 1. The only way that could be true is if x is 0. Convert to a log function. Log base a of x equals y. The conversion is a to the y equals x. Remember, wherever the base is, has to remain the base. So that's the base. So it's log base 10. When you do the conversion, you switch the answers. So now it's log base of 100,000 is equal to 5. Now, since it's log base 10, we don't have to write anything in the base because it's automatic. It's a common log. Right? Let's convert this logarithm. Log base e of k equals negative 4. But log base e is ln. Ln of k equals negative 4. So there's your answer. Ln of k equals negative 4. Convert the exponential. Okay, now this is common log. There's nothing down there. So this one is log base 10 of 0.001 equals negative 4. So when you convert, the base remains the base. It pushes up the answer. So it's 10 to the power negative 4. The log drops off. So we have 10 to the power negative 4 equals 0.0001. Use a calculator to find the common log. So, I mean, this is one of the buttons in your calculator already. So just type in log, or 69 log, or log 69, however your calculator operates. Let me show it to you on mine. Let me see. So, I want to get to me. Oh, there we go. So I want the log 69. Enter. So the answer is 1.8388. Likewise, the next one. Clear it. The next one says log base 10, so it's common log. So log of 0.063. Enter. The answer is negative 1.2007. I don't know how many it's going to want. 4 decimal places. 1, 2, 3, 4. Yeah. Since 1, 2, 3, 4. Since the 5th decimal is a 5. Remember, if it's 5 or 9, round that one up 1. If it's the fifth one is 0 to 4, just drop those off. So it's 2007. Remember, what we're doing here is we have log of x. That's what the calculator is looking for. Remember our graph of logs. Logs like this. So the domain is 0 to infinity. Those are our x values. The reason I say that is because of the next one. It says log of negative 30. It doesn't exist because it's outside the range, outside our domain. Now this one, you can't find a button like this on your calculator. Just remember, all your calculator has are natural log, or common logs, or natural logs. So we have to use a change of base formula. The change of base formula is this. You have log base a of a number. You can use either one of these two. Log of the x, whatever's on top here, divided by log of the base. So let me see here. So we have here in ours, we have log 7 of 17, which becomes log 17 over log 7. So log 17 equals that, divided by log 7. 1.45598. 4 decimal places. 1, 2, 3, 4. Since that's an 8, we add 1 to that. So it adds 1 to that. So it's let's see what happens if you use ln. Will you get the same answer? So we have ln of 17 divided by ln of 7. 455, so it's 1.4560. So again, it doesn't matter what, because it's a ratio that matters. All right, good luck everybody.